This is the short instruction video 2 on the IdematLightLCA app. Since the app is an extension of the Idemat app, you should look at the first instruction video of the Idemat app prior to this instruction video. So now we'll skip the explanation of the bars, the advantages and disadvantages of the eco-cost versus carbon footprint, the 3 end-of-life scenarios, and we skip the use of my favorites in relation to the extensive Excel tables for detailed and complex LCAs. First, what you can and what you can't do with this app. You cannot make LCA of systems with byproducts, since that would make the app too complex. You cannot add the eco-cost of used TOX tables for foreground emissions, since these tables are too big for an app. You cannot handle complex end-of-life scenarios other than the 3 base cases. But what you can do is make cradle-to-grave as well as cradle-to-cradle analysis. You can benchmark the advantage of circular business concepts. You can benchmark the difference of innovative product designs. You can benchmark the difference in service systems. And last but not least, you can calculate the eco-costs of an environmental product declaration, an EPD. This app is for designers, engineers, architects and business managers, since they are interested in quick results. And remember, the calculation results are not less accurate than full LCA calculations, since the tables which are used have been calculated with SimmaPro and the Idemat app LCA database of the Delft University of Technology. Well, let's get started. We start with the example of the first instruction video of the Idemat app. There we had an example on a textile fabric blend, and instead of exporting data to Excel, we will now enter the production flow in our IdematLightLCA app. In our app, we go to LCA projects and start a new LCA project. We fill in the project name and the description. In the description we have the declared unit and information on the system which is studied, such as the system boundaries, the transport scenario and the energy scenario in the use phase. In our LCA input screen we will add all required data lines for materials, processes, transport and energy by pressing the blue button Add Extra Data Line. Then we add the quantities. Beware of the units, especially for transport and energy. You can delete data lines which are not needed by pressing the red cross. When we are ready, we press the Calculate LCA or the Save button and see the results in eco-costs in yellow or carbon footprint in the green field. We can export the data via email pressing the button Export using the standard email system of our smartphone. We can duplicate the data for a new LCA. This enables easy benchmarking of alternative products. Don't forget to give the project a new name. So far so good for the standard calculations. Now we look at calculation of eco-costs of a product with an environmental product declaration, an EPD. Here we take EPDs which are available at the German EPD site of the IBU, Institut für Bauen und Umwelt. Note that there are other EPD databases in other countries in Europe as well. We start with the example of inner separation walls for offices. In this case you can find the materials which are applied in these separation walls for the average office. This is a page from the EPD. Our approach is the same as in the previous example. We fill in the project name and the project description and start adding the extra data lines we need. Carbon steel, aluminum, glass, rock wool, nickel, brass, PP and wood. In this case we take the materials only, since the eco burden of the assembling processes are negligible. We add the transport from the manufacturing site in Turkey to the warehouse in the Netherlands. We fill in the quantities. We delete the lines in the use phase since we'll only be calculating the cradle-to-gate data. Now we press the Calculate LCA button and see the results in eco-cost in yellow or carbon footprint in green. You see the advantage of the circular economy in carbon footprint and eco-costs. The difference between the waste treatment case and the circular economy case is bigger in eco-costs, since eco-cost takes materials depletion and toxic emissions into account. In general, products with metals in it benefit a lot in the circular economy approach, as is clear from this example. With regards to metals, it is important here to mention a list of critical raw materials, CRM, of the European Union. You can see in the category list whether or not a material is on this list by the addition of CRM to the name. CRM means that there is a supply risk of this material because of possible geopolitical tensions. An example is chromium, which is on the CRM list. We can have a look at the list by clicking on the information toolbox. The list shows 3 indicators. The CRM with the CRM sustainability score in the red bars of 2014, the supply risk index of the British Geological Survey in 2015, also on geopolitical risks, and the minimum required recycling rates for 1,000 years of supply of the University of Utrecht 2016. The next example is a product in the building industry of which the content of the product is not known exactly: vitreous china ceramic sanitary ware. We know that there are no metals and plastics in it, so we don't have eco-cost of materials depletion. The EPD at the IBU website gives information on the cradle-to-gate emissions in terms of the most important midpoints: greenhouse, acidification, eutrophication and photochemical oxidant formation, causing summer smog. Most of the EPDs give only the data for cradle-to-gate of the factory, the blocks A1, A2 and A3. In our app, we apply here the data lines of the category with the name EPD midpoints. We enter all the 4 data lines with the name emissions in it and enter the quantities for A1, A2 and A3 from the table in the EPD. We use the EPD data only for the cradle-to-gate calculation. In our app, these are the lines under resources and processes, since the subsequent steps in the product chain are always specific for a given case. This is the reason that more than 90% of the EPDs don't give data on the blocks A4, A5, C and D. When we want, we must fill in our own transport and the use phase data, according to our own scenarios of transport, maintenance and additional use of energy. In the next example, we deal with the situation that the product is partly oil-based, that is to say that it contains resins or other chemicals. Normally, the exact composition of those products is not provided by the manufacturer. Our example is water-based paint from Sigma Coatings. Note that there are no metals in it apart from titanium dioxide for a white color. The table in the EPD shows the cradle-to-gate data for the paint. We add that to our LCA input screen as we did in the previous example, but now we add 2 extra lines for the calculation. The non-renewable primary energy as material utilization, in short NRPM, and the renewable primary energy resources as material utilization, in short RPEM. The non-renewable primary energy as material utilization is used to calculate the eco-costs of depletion of fossil fuels, since the abiotic depletion data must be considered as obsolete. The renewable primary energy resources as material utilization is used only to calculate the credit for combustion with heat recovery at the end of life. In this case, we need the lines of emissions for the use phase as well, since we need the same paint for maintenance during the expected lifespan of the product which is painted. There are EPDs which have typical information on the end of life, like this example of double-skin steel-faced sandwich panels with a coil made of polyurethane. You may add this information of blocks C4 and D to the use phase of our app. Since the app doesn't allow for negative inputs in column D, you need the lines End of Life Credits from the EPD midpoint category. You can find the background information of this kind of EPD calculations by clicking on the Information toolbox. This information shows how to deal with EPDs of products with metals in it, combined with a high energy demand in the processing stage. It also shows how to deal with EPDs of wooden products. When you want to know more on the background of calculations in general, click on the Information 1 box. When you're not acquainted with LCA, you might read the LCA Guide for Design Students and Business Managers, which explains in easy language how to do an LCA in an easy, practical way. Let's get started.